Welcome to another deep dive. Today, we're going to be looking at something that I've always found fascinating, helicopters. You know those machines that seem to just defy gravity, taking off and landing vertically, hovering in midair? They're amazing. We've got a lot of cool stuff to share about helicopters.
Yeah, and it's a journey that starts really far back in history. People have been dreaming about these machines for centuries, but actually making those dreams a reality, well, that was a lot harder than anybody thought it would be.
That's right. It seems like helicopters took a lot longer to get off the ground than airplanes did. Why was that?
The answer's right at the heart of a helicopter. It's the rotor system. You see, unlike airplanes, which rely on fixed wings and that forward momentum to generate lift, helicopters need an incredible amount of power just to lift their own weight straight up. And early engines were just too heavy, too weak to reliably create that kind of lift.
So what changed? What was the big breakthrough? Was it some kind of new engine?
You got it. The turbine engine. It was a huge moment for helicopters. Turbine engines are lighter, they're more powerful, and they vibrate way less than those old piston engines. Honestly, they changed everything about helicopter design.
Okay, so turbine engines gave them the power they needed, but how did that actually make helicopters better?
Well, think of it this way. Before turbine engines, helicopters were pretty limited. Limited in how much they could carry, how far they could fly, how fast they could go. But once turbines came along, suddenly helicopters could lift heavier loads, fly farther, and go faster than anyone had imagined. It was like they finally had the power to reach their full potential.
I can see how that would open up a lot of possibilities. And speaking of possibilities, I understand there are tons of different helicopter designs out there, not just that classic single rotor and tail rotor we usually see.
Absolutely. Helicopter design has branched out in some pretty wild directions, each with its own advantages, depending on what you need it to do. Take tandem rotor helicopters, for instance. Those have two big rotor assemblers that work together. And what's interesting about them is the rotors spin in opposite directions, which cancels out their torque.
Wait, torque? That sounds familiar. That's like a physics term, right? Can you remind me what torque is and why it matters so much for helicopters?
Sure. Torque is basically a twisting force. Imagine you're trying to loosen a bolt that's really stuck. The force you're putting on the wrench to turn it, that's torque. Now, in a helicopter, when that main rotor is spinning really fast to create lift, it also creates a really strong torque that tries to spin the helicopter's body in the opposite direction. And if you don't counteract that torque, well, a helicopter would just spin out of control instead of lifting off.
Ah, I see. So those tandem rotors, with them spinning in opposite directions, they basically just get rid of that twisting force.
Exactly. It's a really smart design because it means you don't need a tail rotor, which is what usually counteracts torque in single rotor helicopters. And without a tail rotor taking up space and power, tandem rotor helicopters can carry a lot more weight and fly pretty darn fast. In fact, some of the fastest helicopters in the world use that configuration.
That's incredible. So tandem rotors are like the heavy lifters, the speed demons of the helicopter world. What other unusual designs are out there?
Well, there's the coaxial rotor design.
Okay.
That one was pioneered by the Kamov Design Bureau in Russia. It's a pretty amazing sight because it has two rotors that are mounted one right on top of the other, and they spin in opposite directions on the same axis.
Wow. I'm trying to picture that. It sounds complicated.
Oh, it is. It's a really impressive piece of engineering. And what's especially cool about it is how stable and maneuverable it is. It makes them perfect for operating in tight spaces, like on ships or oil platforms.
So tandem rotors are for heavy lifting and speed, and coaxial rotors are like the nimble acrobats. Are there any other designs that really push the limits of helicopter engineering?
There's one more I got to mention. It's the intermeshing rotor system. In this design, you've got two rotors mounted side by side, but they're angled so the blades actually mesh together as they spin. Now, it might sound like that would just lead to a big crash, but the timing and the angles are so precise it works perfectly.
I'm having trouble picturing that. Are there any actual helicopters that use this intermeshing design?
Absolutely. The common HH-43 Husky, which was used a lot for firefighting, that's a great example. Those intermeshing rotors let it hover right over fires and make really accurate water drops. And then there's the K-Max, sometimes called a sky crane. It's a heavy lift helicopter that's famous for its ability to carry lumber and other cargo with incredible precision, all thanks to its intermeshing rotors.
So intermeshing rotors are all about precision and control. Okay, so we've talked about all these different types of helicopters, but let's focus on the part that makes it all possible, the rotor system itself. I gotta admit, I'm not really clear on all the details. What exactly is a rotor system made up of?
It's all about using those spinning blades to create lift. At the center, you have the mast, which is that tall, vertical shaft that holds up the whole rotor assembly. Then there's the hub, which is attached to the top of the mast, and that's what the rotor blades are connected to. And of course, you have the rotor blades themselves. Those are the long, aerodynamic parts that slice through the air and create the lift that gets the helicopter off the ground.
It sounds simple enough, but I'm sure there's more to it than just attaching some blades to a stick and hoping for the best.
Oh, you're right about that. And that's where the different types of rotor systems come in. There are semi-rigid, rigid, and fully articulated systems, and they all have that own special way of letting those blades move and respond to the forces of flight.
Okay, so 3 main types of rotor systems. Can you explain the differences between them? What are the pros and cons of each type?
Sure. Let's start with the semi-rigid rotor system. In this one, the rotor blades are attached to the hub with hinges that allow for flapping, but they're also connected by a teetering hinge, which lets the blades tilt as one piece.
So it's kind of like a seesaw with the blades going up and down on each side.
You got it. It's a pretty simple design, and it's lightweight, which makes it really popular for smaller helicopters. However, it's not quite as maneuverable, especially at higher speeds.
I see. So what about rigid rotor systems? I bet those are a lot stiffer.
You guessed it. In a rigid rotor system, the blades are fixed directly to the hub. No hinges, no flapping. This makes for a really responsive helicopter that can move quickly and precisely, but it can also make the ride a bit rougher because it transmits more vibrations to the airframe.
So it's a trade-off between responsiveness and a smooth ride.
Exactly. Now, fully articulated rotor systems are the most complex ones. They have multiple hinges that let the blades flap, feather, which is changing their angle, and lead lag, which is moving back and forth.
Wow, a lot of motion. So what's the advantage of all that flexibility?
Well, think about how a bird's wings move up and down. That's flapping. Feathering is like when you change the angle of your hand in a stream of water. It's adjusting the blade angle to control lift. And lead lag is a more subtle movement where the blades move slightly forward and backward. All those movements allow the blades to adjust their pitch and position individually, which results in a much smoother ride, better stability, and improved handling, particularly in turbulent conditions.
So it's the top-of-the-line rotor system, the one that gives the pilot the most control.
You could say that. It's what you'll find on larger helicopters and ones that are designed for tough missions, where a smooth ride and really precise control are essential.
Makes sense. It sounds like choosing the right rotor system is really important when you're designing a helicopter for a specific job.
Absolutely. Each system has its strengths and weaknesses, and engineers have to think carefully about weight, performance, and how the helicopter will be used to pick the best system.
This is where it gets interesting for me. Just knowing about these different systems makes me appreciate all the engineering that goes into every single helicopter design. It's not just about throwing some blades on a shaft and seeing what happens.
You're exactly right. And as technology keeps getting better, we can expect to see even more advanced rotor systems being developed, pushing the boundaries of what helicopters can do.
Well, before we get too carried away talking about the future of helicopters, let's get back to that problem of torque. We talk about how tandem rotors cancel it out by spinning in opposite directions, but what about single rotor helicopters? How do they handle that twisting force?
That's where anti-torque controls come in. They're the key to keeping a helicopter stable and pointed in the right direction. You could call them the unsung heroes of helicopter flight.
Okay, so they're important. What are some of the ways engineers have tackled this torque problem?
There are 3 main types of anti-torque controls. The most common one is the tail rotor. You've probably seen it on countless helicopters. It's that small rotor mounted vertically on the tail boom, and it creates thrust in the opposite direction of the main rotor's torque, effectively canceling it out.
So the tail rotor is basically a little counterspin. It keeps the helicopter from spinning out of control.
That's exactly it. And then there's the fenestron, which is also known as the fan tail. It's basically a fan that's enclosed in the tail, and it looks pretty futuristic, and it's a lot quieter than a traditional tail rotor.
Oh, that's interesting. A quieter and more visually appealing solution. What about the third type?
The third one is called the NOTAR system, which stands for no tail rotor. It's a pretty clever system that uses a fan inside the tail boom to create a layer of high-pressure air. Then this air is pushed out through slots along the tail boom, and that creates a force that counteracts the torque from the main rotor.
No tail rotor at all. That sounds kind of magical. I'd love to learn more about how that works.
It really is a fascinating use of aerodynamics. If you want to learn more about these anti-torque systems, I'd recommend taking a look at Chapter 4 of our source material. It's got a great explanation of the different approaches and how they've evolved.
Perfect. I'll add that to my reading list. But for now, let's move on to how a pilot actually controls one of these amazing machines. I have a feeling it takes a whole different skill set compared to flying an airplane.
You're absolutely right. Flying a helicopter is often compared to conducting an orchestra. It takes a delicate touch, perfect timing, and a constant awareness of all these different controls working together.
So what exactly are the instruments a helicopter pilot has to play?
A helicopter has four main controls: the cyclic, the collective, the anti-torque pedals, and the throttle. Each one has a specific job to do in controlling the helicopter's movements.
Okay, let's go through them one by one, starting with the cyclic. What does that control?
The cyclic, which is kind of like a joystick, controls the tilt of the rotor disc. Think of it like tilting a plate. If you push the cyclic forward, the rotor disc tilts forward, and that makes the helicopter move forward. Pulling it back makes it go backward, and moving it sideways makes it go left or right.
So the cyclic is for steering. What about the collective? What does that do?
The collective is a lever that's next to the pilot's seat. It controls the angle of all the rotor blades at the same time. By changing the blade angle, the pilot can make the helicopter climb or descend, want to go up, pull up on the collective, need to go down, lower it gently. It's all about controlling the helicopter's altitude.
Okay, cyclic for direction, collective for altitude. Got it. Now, what about those anti-torque pedals? What do they do?
They're a lot like the rudder pedals in an airplane. They control the tail rotor or whatever other anti-torque system the helicopter uses. The pilot uses them to adjust how much thrust the anti-torque system is producing, which helps keep the helicopter pointed in the right direction.
So they're like the fine-tuning control to prevent the helicopter from drifting off course. And finally, we have the throttle. I'm assuming that one's pretty self-explanatory.
You're right. The throttle is basically like the gas pedal in a car. It controls the engine power, which directly affects how fast the main rotor spins. Keeping those blades spinning at the right speed is really important for stable flight.
So the throttle keeps those blades humming along at the perfect RPM. It sounds like a lot for a pilot to handle. With all these controls working together, it must be like a dance.
That's a great way to put it. It's that delicate balance of all those controls that allows a skilled pilot to do those amazing maneuvers and landings. It's really a testament to both human skill and the brilliant engineering behind these machines.
Speaking of precision, let's talk about hovering, which is probably the hardest part of flying a helicopter. I've always been amazed by how a helicopter can just hang in the air, seemingly defying gravity.
Hovering really shows off a pilot's skill and the incredible design of the helicopter. Imagine trying to balance on a huge spinning plate while fighting against your own turbulence.
That sounds like a recipe for disaster. What makes hovering so difficult?
Well, when a helicopter is hovering, it's basically in a constant battle against the forces of aerodynamics. The pilot has to make tiny adjustments to the cyclic, collective, and pedals all the time to counteract wind, turbulence, and the helicopter's own downwash. It's a dynamic balancing act that takes a lot of focus and skill.
So how does a helicopter go from that delicate balancing act of hovering to flying smoothly forward?
That's where all those controls really have to work together. To move forward, the pilot tilts the rotor disc forward using the cyclic. It's a bit like leaning into a turn when you're riding a bicycle. This tilt changes the direction of the lift force, which makes the helicopter move forward.
And I imagine the collective and pedals come into play here too.
Absolutely. As the helicopter picks up speed, the pilot adjusts the collective to stay at the right altitude and uses the pedals to keep the nose pointed in the right direction. And there's another interesting detail here. The horizontal stabilizer, which you often see on the tail boom, that actually helps keep the helicopter level and reduces drag when it's flying forward. It's all about how those aerodynamic forces work together.
It's amazing how all those subtle changes in the controls work together to make the helicopter move.
It is. Experienced helicopter pilots develop a real feel for their machines, almost like an instinct for how to respond to changes in the wind and air. It's something special to see.
Well, we've covered a lot of ground in this deep dive, from the early days of helicopter design to the complicated controls that let them fly. But there's still so much more to explore. Stay tuned for part 2 of our deep dive into the world of helicopters, where we'll delve into their advantages, talk about safety considerations, and look at the exciting future ahead.
Looking forward to it. There's a lot more to uncover about these remarkable machines. Welcome back. I'm really looking forward to diving into what makes helicopters so special and why they've become such important tools in so many different fields.
Yeah, I'm excited to hear more about that. We
Yeah.
talked about how hard they were to design, but those challenges have obviously been overcome because we see helicopters everywhere these days. What are some of the biggest advantages they have over traditional airplanes?
Well, the most obvious one is their ability to take off and land vertically. Helicopters don't need runways, so they can operate in places that airplanes could never even dream of reaching,
Hmm.
like remote mountaintops, dense forests, or even the decks of ships.
That's right. That's why they're so crucial for things like search and rescue missions, right?
Yeah.
They can get to places where airplanes just wouldn't stand a chance.
Exactly. And it's not just about getting there, it's about what they can do once they arrive. Helicopters can hover precisely over an area, whether they're rescuing someone, lowering equipment onto a construction site, or transporting a patient to a hospital.
I remember seeing footage of helicopters being used to fight wildfires. It's incredible how they can drop water with such accuracy right onto the flames.
Absolutely. Helicopters have become absolutely vital for firefighting. Not only can they make those targeted water drops, but they can also transport firefighters and their gear right to the front lines, which is essential for containing those fast-moving fires.
So we've got search and rescue, construction, firefighting. What other areas have really benefited from the unique things that helicopters can do?
Well, think about transportation. Helicopters can quickly transport people and goods over traffic jams and difficult terrain, bypassing all those obstacles that would stop other vehicles in their tracks. They're essential for all sorts of things, from emergency medical evacuations to scenic tours to executive travel.
Imagine just flying over rush hour traffic in your own helicopter. What a time saver. But let's be real, helicopters can't be perfect, right? There must be some drawbacks too.
You're right, there are trade-offs like with anything else. Helicopters tend to be more mechanically complex than airplanes, so they need more frequent maintenance and are generally more expensive to operate.
And they're not exactly known for being fuel efficient, are they?
Yeah, that's another important consideration. Those powerful engines, while necessary for lift and maneuverability, do burn a lot of fuel. It's something that a lot of research and development is focused on these days, exploring more fuel-efficient designs and looking into alternative power sources like electric or hybrid electric systems.
So there's definitely room for improvement when it comes to sustainability. What about speed? I'm guessing helicopters aren't breaking any speed records.
That's true. Helicopters are generally slower than airplanes, especially when it comes to covering long distances. Their design is all about vertical lift and maneuverability rather than pure speed.
But sometimes it's about enjoying the journey, not just getting to the destination, right? Speaking of journeys, what about safety? There's always some risk involved with flying, but are helicopters inherently more dangerous than airplanes?
That's a tough question to answer. Helicopters do operate in more demanding environments, often at lower altitudes and closer to obstacles like trees, power lines, and buildings. That requires a really high level of skill and precision from the pilot.
And those spinning rotors can look pretty intimidating, especially when you're close to the ground.
Yeah, safety is paramount in helicopter operations, and there are very strict training and maintenance procedures to minimize those risks. It's also important to remember that advances in technology like stability augmentation systems and more sophisticated navigation equipment have made a huge difference in helicopter safety over the years.
So while they might not be for everyone, it sounds like helicopters have come a long way in terms of safety.
They really have, and the industry is constantly working to improve safety for both pilots and passengers.
Okay, before we wrap up this part of our deep dive, I'd love to get a glimpse into the future. What are some of the exciting trends and developments that are shaping the world of helicopters?
One area that's particularly exciting is the development of electric and hybrid electric helicopters. As battery technology keeps getting better, we're seeing prototypes that are quieter and more environmentally friendly.
Quieter helicopters. Sign me up. Imagine a world where helicopters don't make all that noise as they fly around.
It's a really appealing idea, isn't it? And using electric power could also make them cheaper to run and easier to maintain, since electric motors have fewer moving parts and tend to be more reliable than combustion engines.
So it's a win-win for both the environment and the people operating them. Are there any other technological advances on the horizon that you're particularly excited about?
Absolutely. There's also a lot of work being done on autonomous flight. We're already seeing unmanned drones being used for various tasks, and it's just a matter of time before we have autonomous helicopters flying around doing complex missions like delivering cargo, conducting aerial surveillance, or even transporting passengers.
Autonomous helicopters. Sounds like science fiction come to life. What are some of the potential benefits of that technology?
The possibilities are huge. Autonomous helicopters could be crucial in disaster relief efforts, delivering supplies or rescuing people from dangerous areas without putting human pilots at risk. They could also completely change industries like logistics, agriculture, and infrastructure inspection.
It's amazing to think about how autonomous helicopters could make our lives better and make certain jobs safer and more efficient. Are there any other trends we should be paying attention to?
Well, there's the ongoing development of advanced materials and manufacturing techniques, which are resulting in lighter, stronger, and more aerodynamic helicopters. And we're also seeing artificial intelligence and machine learning being integrated into helicopter systems, which makes them even smarter and more adaptable.
It sounds like the future of helicopters is incredibly bright with all kinds of potential for innovation and exploration. I feel like we've only just begun to understand what these machines are capable of.
I completely agree. The next few decades are going to be an exciting time for the helicopter industry. Who knows, maybe one day we'll be recording a deep dive episode from our own personal helicopters soaring above the city.
Now, that's an episode I wouldn't want to miss.
Okay, before we get carried away with our helicopter dreams, I think it's time to shift gears and go back to those different types of rotor systems we touched on earlier.
Great idea. We talked about semi-rigid, rigid, and fully articulated systems, but I think it's worth taking a closer look at what makes each one special and how they affect a helicopter's performance.
I'm all for it. Let's start with the semi-rigid rotor system. You mentioned that it's commonly used on smaller helicopters. What makes it a good choice for those types of aircraft?
The main advantage of a semi-rigid rotor system is that it's simple and lightweight. Remember, those blades are connected to the hub with a teetering hinge, which lets them tilt together. Well, that means there are fewer parts and less complexity compared to the other systems, which makes it ideal for smaller helicopters where weight and simplicity are really important. So it's all about efficiency and keeping things simple. But you also mentioned that it's not as maneuverable, especially at high speeds. Can you explain that a little more?
Sure. Because of that teetering hinge design, the blades can only tilt together, not individually. That limits how much control the pilot has over the helicopter's movements, especially when you're going faster and those aerodynamic forces get stronger.
So it's a trade-off between being simple and being agile. What about rigid rotor systems? How do they compare when it comes to maneuverability?
Rigid rotor systems, well, they live up to their name. They're all about responsiveness. Because the blades are attached directly to the hub with no hinges, they react instantly to whatever the pilot does. This makes rigid rotor helicopters super agile, capable of making those sharp, precise movements.
So they're like the sports cars of the helicopter world.
Yeah.
Quick and nimble, but maybe not as comfortable.
I like that analogy. Rigid rotor systems are great for maneuverability, but they can be a bit more sensitive to turbulence and gusts of wind, which can mean a bumpier ride for the passengers.
Okay, so rigid rotor systems are all about performance and responsiveness, even if it means a slightly less smooth ride. Now let's talk about the most complex of them all, those fully articulated rotor systems. You call them the deluxe option, the choice for larger helicopters and tough missions. What makes them stand out?
Fully articulated rotor systems are really a marvel of engineering. They allow for the most blade movement with hinges for flapping, feathering, and lead lag motion. That independent blade movement gives the pilot a lot of control over the helicopter, even when things get turbulent.
So they're like the ultimate all-terrain vehicles built to handle anything the sky can throw at them.
Exactly. Fully articulated rotor systems provide a smoother ride, more stability, and better handling than the other systems. They're a must-have for helicopters that operate in challenging environments, perform those complex maneuvers, or carry heavy loads.
It really seems like choosing the right rotor system is crucial to making sure a helicopter is right for the job.
Absolutely. It's one of the most important decisions in the design process. Engineers really have to consider the mission, the performance goals, and the environment the helicopter will be operating in to choose the best rotor system.
Well, now I'm even more impressed by the engineering behind these machines. It's amazing to see how every single component from the engine to the rotor system has such a big impact on how a helicopter performs.
It really is a testament to human creativity and our determination to conquer the skies.
Welcome back for our final descent into the world of helicopters. We've covered a lot of ground, their history, mechanics, capabilities, but what I'm really curious about is how they're actually shaping our world today and what's next for these incredible machines.
Well, helicopters have really gone from those almost mythical machines struggling to get off the ground to these essential tools we see in so many industries. It's been quite a journey.
It really has. Earlier, we talked about how they're used in search and rescue, firefighting, construction, transportation. It seems like they're everywhere these days.
They really are, and it's amazing how their roles keep evolving as technology gets better. For example, we're seeing helicopters with more and more advanced sensors and imaging systems, which are turning them into these powerful tools for things like environmental monitoring, surveying, and even archaeological research.
Wait, archaeological research. Now I'm picturing Indiana Jones hanging from a helicopter over some lost city. How are they using them in archaeology?
Haha, maybe not quite like Indiana Jones, but they do play a big part in modern archaeology. They can create those high-resolution aerial maps of archaeological sites, revealing details and patterns you just wouldn't see from the ground. And they can also transport archaeologists and their equipment to remote and hard-to-reach places, which opens up a whole new world of research opportunities.
That's incredible. So helicopters are helping us understand the past while also shaping the future. Speaking of the future, we talked about electric and hybrid electric helicopters and autonomous flight. Are there any other advancements that you're excited about that could really change the game for helicopters?
One area that's really taking off is urban air mobility, or UAM. It's this vision of a future with a whole network of electric aircraft, including helicopters operating in urban airspace, providing on-demand transportation within and between cities. Think flying taxis.
Well, that sounds futuristic. Flying taxis zipping through the skies above our cities. It's mind-blowing.
Oh.
What are some of the challenges that need to be addressed before we see this become a reality?
There are definitely some hurdles. We need to develop aircraft that are super safe and reliable, create really robust air traffic management systems for that urban airspace, and address concerns about things like noise and public acceptance. But the potential benefits are huge. Think about reducing traffic congestion, making commutes easier, and enabling new forms of transportation and logistics.
It's definitely a future I'm excited to see. What about other areas where you see helicopters playing an even bigger role in the years to come?
One area that often gets overlooked is their potential in disaster relief and humanitarian aid. Helicopters are already being used to deliver supplies, evacuate people from dangerous areas, and provide medical assistance after disasters. But as they keep getting more advanced, I think they'll become even more vital in responding to natural disasters, conflicts, and humanitarian crises.
That's a great point. Helicopters can often reach places and provide assistance in ways that other vehicles just can't, especially in those critical first few hours or days after a disaster.
Exactly. They can be a lifeline, delivering essential supplies, transporting medical teams, and providing aerial reconnaissance so we can assess the situation and coordinate relief efforts.
As we wrap up this deep dive, I have to say, I'm leaving with a whole new appreciation for helicopters. They're not just these amazing machines that defy gravity, they're incredible tools that are making a real difference in our world. From saving lives to enabling exploration to pushing the boundaries of what's possible.
I couldn't agree more. And the best part is, this is only the beginning. As technology keeps advancing, I have no doubt that we'll find even more innovative ways to use helicopters.
So listener, the next time you see a helicopter flying overhead, take a moment to think about everything we've talked about, the ingenuity of their design, the skill of the pilots who fly them, and the countless ways they're making our world a better place.
And remember, as we continue to explore and innovate, the sky is the limit.
Until our next deep dive, keep exploring, keep learning, and keep looking up.